Hello and welcome to British Academy. Today we'll be talking about working with functions from the book Math for Programmers of Paul Orwand, and we will stop ourselves on the following 4 topics, pretty much giving functions more inputs, keyboard, keywords argument, functions as data, lambdas, and applying functions to NumPy arrays. So let's start. And here we are working with Jupyter Notebook. And the first thing that we need to say about a function, pretty much in Python, is that it starts with the word def. And this is a function, for example, def square x. And we write pass just to avoid writing anything and to make our code pretty much executable. What is a function in general? Well, if you need to define it, that's really a philosophical question. Probably you can go up there, but it's a code that now carefully it might have an input, might do some calculations, and might return an output. In the best case, it will have an input. As our case, we'll do some calculations, like in this case the result would be x times x, and we'll return an output like this, and this is how it is executed. And square of 23 is 529. Yeah. So let's see what can we do now. The first point in the chapter that we are looking at is pretty much giving functions more input, and we can say, yeah, let's give it more than once. We can say I'll say add 4, it could be x, y, z, and then zz. These are our variables, and they will be returning x plus y plus z plus zz with spaces between the pluses. So if I need to call it, it would be something like add 4, and it would be 1 plus 2 plus 3 plus 100. This would be 106. Yes, that's the way. And if we don't want to write it like this, we can write a function called def add, just add. And here we will use a star, and you'll say, okay, whatever I give as an argument, it will go. This is not actually arguments. This is not like a reserved word, but it's a word by design in a lot of languages. So we'll use this one. So to tau equals 0 for x in args, we can say to tau equals plus and equal x, which means that it's going to sum every x on the loop, and then we are going to return to tau. Yeah, and we can say, okay, add 1 2 3 4 5 6. Of course it works. What is actually interesting here is that we have a second option what to use the star for. The star could be used as pretty much taking a list and converting it into the argument of a function, which means we'll take this list here like that. I'll put 11, and it would be called a. That's a bad name of a variable, but anyway, for the current purposes it would be okay. And we can say add, and we can say add 4, for example, like the one above. And if we do it like this, of course, it says 3 missing arguments, required positions, y, z, and zz. Pretty much it only found the first one, and then it was unhappy. But if we add the star, then something bad happened, because we have one more number. They are not 4. Now it will be okay. Yes, now it works. So this is a second option what to do with the star. Okay, now let's switch to keyword arguments. Pretty much the example in the book was the function birthday, and we have an option as a keyword saying, okay, this is friend, and the age is going to be none. It's like if you have a friend to whom you don't know the name, you can use the word friend in the function. So what is it going to do? It's like going to say happy birthday, and here it will be the name, pretty much like that. And if age is given or not none, with other words, then the result would be just a pending, and then the same f string. So there would be comma space UR age years old. Yeah, and that's it. Return result plus this bad boy. So let's code like this: birthday, and we see the function. If we execute it, happy birthday friend, fair enough. Yeah. If we say, okay, happy birthday, let's say Vitos, that's my name. Happy birthday, Vitos, great. Vitos is 333 years old. Yeah, this is what it said. And now the interesting part, we can go like that. Name equals Vitos and age equals 333. Yeah, fair enough. What is interesting is that we can say, okay, birthday person is a dictionary, and this pre-dictionary has an age, and the age is something like that, and then it has a name, and the name is my website. Yeah. Okay, it's called product placement. Let's see, birthday person didn't like something. Yeah, that's kind of interesting. Why? Okay, birthday person age. Yeah, that's something that I usually do as a mistake, kind of a rookie mistake. Probably I'm a rookie then, I don't know. No, it happens to everyone. Just forgot that in the dictionaries you have used you have this operator instead of that one. So that's the result. And now I'm showing you this. The reason is that we can say, hey, birthday, and then we can unpack with two asterisks, and then we can say birthday person. Yeah, happy birthday, Vidush Academy. You are, I think, around 14 years is the website. Okay, 12, somewhere there. Happy birthday, Vidush Academy. You are 12 years old. Yeah, fair enough. So far, so good. And now let's go to the third point of our video. We're going to talk about functions as data. So pretty much functions are first-class citizens. What does it mean, first-class citizen? You can assign them to variables, pass them to functions, and return functions as output values of other functions. Okay, let's see the first. How do we assign function to variable? Okay, def evaluate, and then we have f of x, and then return f of x. So here we pass the function, here we have the variable, and here we return function, and then we execute it. Fair enough. And that's what we have as an example. Evaluate and then square. This is the function from here. And it's not okay to do it like this. The function is f and x is the variable. So yeah, that's the variable of this one, or the variable of 111. The square of 111 is this one. If we say print from the square function, just to see that it is here, we press Control Shift and Enter, to run this function, so it's 37 the number now, and if we run it from here, it's simply said from the square function. Okay, runs, everyone is happy. Runs, everyone is happy. So next, what we can do further is we can map functions like this, like list, then map, then square, and then range of 10. Okay, what would this tell us? This would give us the numbers from 1 to 10, from 0 to 10 or something, 1, 2, 3, 4. And it will map them. This function, it would map the function square to the value produced here, and it would produce it to a list. Yes, so how many values did range 10 return? Plenty, if you want to be sure. You can do something like this, just to see. Okay, from 0 to 9, fair enough. Works okay. Now, a more interesting thing that I already mentioned is that we can pass functions to functions or return functions as outputs of other functions. Yes, this is what we're going to do. So def make power functions power, and then this is the function that we're going to return, power function, or we can call it simply f. Yeah, not the best name. X power, and we are returning f. As simple as that. So our variable would be new variable, not the best name, new variable that becomes function. That makes sense. And we're going to say, okay, make power function of the variable 22. So if I go simply like that, ta-da, somehow it works. And if I say, okay, 5, it's unhappy because it already knows that 22. Yeah, it's x to the power of that one. Wow. So yeah, to the 22nd power. Okay, let's do something that I kind of can follow. Yeah, 5 to the power of 2 is 25. It actually makes sense. Yeah, so far so good. We're on the fourth version, the fourth section with lambdas. Lambdas are anonymous functions. Why shouldn't a function have a name? That's a good question. And sometimes functions don't need names if they are going to be used once or twice in the code. This is what I've been told. This is what I'm going to try to sell it to you. I don't remember how it was written in the book, but probably something in this area. So very much lambda x returns the variable plus 2, which is great. And if I want to use this function, I cannot call it, of course, unless I don't do something like this, but I doubt. Yeah. What about? Yeah, doesn't work. What about? No, still doesn't work. Okay. So simply copying this one, and it's gonna be lambda x plus 2, and then 10. Yeah, 12. So what happened? We executed this function here, and it returned x plus 2, and for x we gave 10, so 10 plus 2 is 12. So far so good. Do we need to have this one ever? No, we can say, okay, for example, I'm having a lambda function that whenever it's called, return pi. Ta-da. Not very sure what this can be used for, but I mean this specific one. But let's continue then. We have lambdas xy returning, for example, x plus 2 to the power of y. 2 to the power of y, and here we can call it, let's say, with 3 and 4, and it's a nice number. Okay, 3 plus, so we have 2 to the power of 4, which should be something like 16 plus 3 is 19. So it works. I'm not checking actually Python, just FYI. The last thing is about lambdas. We can assign lambdas to a function. For example, the so-called +2 would return lambda x plus 2. Okay, this is an overkill. If you ever see it in a code, yeah, simply talk seriously with the guy who is producing it, because you really don't have reasons to do this, but it works, yeah, which is good to know. What can we do? We can map lambda's function x plus 2 and the range from 0 to 10, which looks like this. If I do this, it would be an error. So what should I do in order to see the results? I can call it like that, which is an ugly way, and it wouldn't work. Or I can do like this list, and we see the list. Yeah. Okay. Last point, applying functions to NumPy arrays. So in order to have NumPy or NumPy, we have import NumPy as MP. So MP sqrt. These are like built-in functions in this huge NumPy library. Actually, NumPy comes from numeric Python, so it's really fast with numbers. So NumPy arrange is not written with 2 R's, or just 1. So 0, 10. What is going to happen here? It is pretty much going to give the square number of every number in this range. So square of 0, 0, square of 1, 1, and so on. It's not square, it's square root. Okay. Yeah, if it was square, it's gonna be different one. Okay, and last but not least, if you want to apply a custom function to every entry of a NumPy array, you can use the MP vectorize function. So a function that we can vectorize is something like the standard check whether a function is divisible by 2 or even or odd. Okay, so if x divided by 2 equals 0, this means return it, otherwise, yeah, this is pretty much the either or. I can explain 123 divided by 2 is 1, and 122 divided by 2 is 0. So it's, yeah, odd and even. And if we want this function really quickly to be vectorized, so we name it my NumPy function, and it's gonna be MP vectorize my function. So this is what comes from NP, the vectorize thing. And we can really say, okay, then my NumPy function, and we use this NP arrange from 0 to 10, and this is what it returns us, really quickly execution of the function. Okay, so far so good. Thank you for staying with me so long, whole 18 plus minutes, and enjoy the rest of your day. Take care. Bye.